As you can see in Excel building process, it's very important to organize your data and label all the numbers very easily so you don't make a mistake. Here Jack is calculating the average heartbeats from the technical replicates that been collected during the lab, and he's populating averages for the baseline and the treatment for each Daphnia. And as you can see, he's using the black cross to pull the formulas down, and then he double checks that the formulas didn't change. It's a very good habit to double check that the formulas don't change once you pull them down or horizontally. Here he's calculating percent change of the heartbeat, so pay attention to the formula that he's using. In the same way, he's using the black cross to pull the formula down to populate it for all three Daphnia replicates, and he's double checking that pulling was successful and accurate. Now he's calculating the average for the change for each treatment, ethanol extract and Benadryl. And he's calculating also standard deviations for each of those treatments, so he can build a bar graph. So he's moving towards building the bar graph right now. He's going to select both averages for the methanol extract and Benadryl. Although it's an option to just select one, you can always adjust it down the line, as you will see later. And you go to insert bar graph, and this is your basic bar graph. He's going to customize it now by creating a descriptive title that tells the audience what we're supposed to see here. So it should be something percent change of the heartbeat or effect of sage on the heartbeat. And then you go to select data, and this is where you can create two series. One here, the first series will be the white sage, and he is renaming it. And he's selecting this specific value. For the white sage, it's a single value. And then for the series 2, it's going to be Benadryl, so he's selecting the average percent change for the Benadryl. And this is how you get different colors on your bar graph. And this is how you can create a legend for those colors. Now he's moving on to creating error bars. So right now he just selected the blue bar, which is a methanol extract. For methanol extract, you only need to select one value, standard deviation. And as you can see, he selected 2. He realized that, so he's removing the second cell. And in your case, you can just select a single cell to start with. Now he's clicking on the orange bar, so you can see it's highlighted. And you select the separate arrow bars for this just orange bar. And again, you just select the standard deviation for the Benadryl this time around. So as you can see, now those two bars have distinct size specific arrow bars that represent standard deviations for each treatment. This is how you create labels for the axis, and make sure to use the units when describing your axis title. At this point, Jack is ready to do his statistics. He's going to Wasserstats to perform t-test. He's going to use independent samples because Daphnia were independent from each other. So he needs to select 3 values of change for the extract and 3 for the Benadryl. So he wants to see if the effect of Benadryl is significantly different from the effect of methanol extract. So yes, two-tailed p-value is 0.02, which means that Benadryl has a significantly stronger effect than a methanol extract, although both of them influence the heart rate of Daphnia. And if you want to evaluate the significance of a specific treatment on Daphnia heart rate, then you will run a t-test between the baseline and the treatment. And I'm using the below table, which already has an averaged technical replicates here, but I'm comparing the data between different Daphnia. So I would compare the baseline of 3 different Daphnia, and I'm going to t-test. And this time it's correlated samples because those Daphnia have exactly the same heart rate. It's the same Daphnia basically. So I'm using a correlated sample and calculate. So this p-value suggests that the methanol extract has a significant effect on the heart rate change.